In this video, we will review the real number system, all of the different types of numbers within the system, and the relationship between those numbers. We will be using a visual representation, also known here as a Venn diagram, to show the relationship between sets of numbers. Here in the middle, at the very beginning, we have what are called the natural numbers, often referred to as our counting numbers. Examples of natural numbers are counting numbers 1, 2, 3, 4, and this list goes on to positive infinity. Our next set of numbers are represented here, and these are called our whole numbers. Our whole numbers include the natural numbers, but also the value 0. And so the relationship between these two sets is that every single natural number, 1, 2, 3, 4, all the way to infinity, is also a part of the whole number set. Our next set are going to be called our integers. These are our natural numbers and whole numbers, but also includes their opposites. So for example, the opposite of 4 is negative 4. The opposite of 7 is negative 7. Those are called our integers. And so the relationship between these three sets so far is that every natural number is also a whole number. Every whole number is also an integer. Our next set is our rational numbers. These are representative of fractions, decimals, and percents. Natural set, the whole set, and also includes integers. I've included here some examples of rational numbers: 2 and 5/10, 77%, and 0.333 repeating. All of these can be represented as a fraction in fraction format. Even this repeating decimal can be represented as the fraction 1/3. So that represents our rational set. A new set of numbers we're going to discuss today is this set over here, and the relationship that it has with all the other sets inside of our real number system. So this set here is called our irrational numbers. And so irrational numbers are numbers that cannot be represented in fraction format. One of the most common irrational values is pi. Not just 3.14 pi, but have you ever Googled what pi actually represents? It's a never-ending value, and it is irrational because there is no pattern or repetition in the values like you might see in 0.3333 repeating. So again, irrationals represent values that cannot be written as fractions. And so even though irrationals look like they have no relationship with our rational numbers, our integers, our whole numbers, or our natural numbers, they're kind of set off here to the side. They are part of the real number system. All of the numbers that we are utilizing are real numbers. Let's try this quick example. Negative 10 over 2, which also represents negative 10 divided by 2. When we evaluate this, we'll get a value of negative 5. Now, negative 5 is an integer. But because it's an integer, it's a part of the rational number system and the real number system. So negative 5 is an integer. Try the Google form that's been assigned to you to see if you can describe the relationship between sets inside of the real number system.